in this particular video we'll be talking about the top 10 interview questions of data engineering. I have segregated, see, it is not a fixed question that exactly it will be asked, but there are many related questions that can be taken from these 10 questions, and definitely these 10 questions can be also asked. So it will give you an idea of what type of preparations you should do if you are getting into data engineering or if you want to get into data engineering. So I have tried to gather all sort of questions from different things so that it becomes that top 10. Okay, so let's start about those, and here it is. So here, as you can see on the screen, this is a production level questions firstly that I'll be talking, and I'm not going to talk about what is indexing, what is partitioning. I am exactly going to talk about how you can how exactly the questions are asked if you are in your second round of the technical discussion or third round of the technical discussion with say the package of 30 LPA, 25 LPA, 35 LPA, these kind of packages. Okay, so here is the first question. That is why firstly I'll tell you what is the mindset of a person who is taking the interview, because I have been on both of the sides. I have taken the interviews, I have given the interviews, so I have been on both of the sides, so I can guide you in the much better way. That is a gap between, what is a gap that you have to fill to get more and more offers, to get through more and more interviews. So that is basically that people are just memorizing the tools. They are not aware about the real fundamentals of the things, how is it exactly the Spark is working, how exactly the things are working. They are just listing the things कि हाँ Spark है, Kafka है, airflow hai, those kind of things they are having, but exactly though they are not aware about those things. Next thing, they are not able to explain the syntax. They just recite the API calls inside instead of discussing the trade-offs or designed discussions. They are not doing. They are exactly talking about the API calls and all. Next thing is basically ignoring the performance. They are not focusing on the performance and cost is the key metrics. You have to talk about those things. You cannot just do random wide transformations everywhere and you can think I am getting the answer. No, your program will fail or your pipeline will fail at the production level. So you are not able to debug the things. Very, very important to understand. So it is, interviews are not just thinking, test the thinking of your data engineering thinking or the business impact thinking. It is not just about the tools ki, you know these tools, yes, you will be hitting hard. No, that is not how the things happen. So here's the first question. Basically what is happening right now, your Spark pipeline is becoming 5x slower. What is the scenario? Basically the scenario is a Spark job processing 800 GBs now takes 3 hours instead of 40 minutes. Like previously it was taking 40 minutes, now it is taking 3 hours to process that 800 GB of the data. Nothing in the code changed last sprint. Basically that change did happen. So walk me through how basically you will debug this. So this is a very good scenario based question, and in this basically the interviewer is asking, the scenario is 800 GB previously was taking 40 minutes, now it is taking 3 hours. So walk me through how you will debug the things, how you will figure out ki basically what all things are. So answers is like this. The first one is basically that Spark UI stage analysis I'll do. That is Spark UI stage analysis you will do, that different, which is the slowest stage, why it is taking time, where it is taking maximum time, that I'll figure out. Next thing is basically shuffle size I'll take, that changes. The shuffle size changes how much if it has increased drastically, definitely your program will be going slow. So that I'll try to figure out. The partition skewness I'll figure out. GC time spikes I'll see ki basically, and memory spills, what is happening to the disk, that I'll try to figure out. Next thing is upstream data growth. How much data growth, how much data was coming, now how much data is coming. Schema drift to nahi ho gaya, so basically that all things I'll try to. Recent code or config change, if there is any config change impact also, any problem in the table change impact or any kind of changes that have been done, that I'll try to see what impact has been happened. So this will evaluate basically my systematic mindset, and the weak answer will be just increase the executor memory. Basically these kind of answers I have seen, and people are not debugging, people are just saying kya increase your memory. It will cost you also, na? If I increase the memory 100%, it will cost me also. So basically I cannot just randomly increase the memory, randomly increase the executor memory. That is now how the things happen. Next question is basically partition strategy on the 2 TB table. So basically the question is here, that is we are having a table. The scenario is you are having a design where you are designing a warehouse fact table. You are designing that ingests 2 terabytes of the data daily. 2 terabytes of data daily it is getting ingested. So analyst query by date range 90% of the time. Basically they give the date range in the query, like select this from this, and where this date range they will get. That date is less less than this and greater than this. So how would you choose the partition column? Basically, what is the partition column you are going to choose? So basically, what is the answer for it? The strong answer, the good answer will be partition by query pattern, usually date for the time series workloads. Then you have to do a partition on the date. Next thing, avoid high cardinality column. If you are having millions of partition, basically on that column you should not do the partition. You should do a partition on the type of the column having low cardinality column pe partition you should do. Next thing is basically ensures the partition pruning in the downstream queries, very important, and address the small file problem. If you are having say multiple small files, so you have to compact, you have to optimize those things, and you have to compact that so that bigger amount of files are there, bigger multiple files will be there. It will be easier and faster rather than smaller more files. It will cost you more time. Okay, that is very important. So this evaluates your warehouse designing clarity, and weak answer can be I would partition by customer ID since it is a primary key. It is not a good answer. You have to partition on the query on which the most of the querying are done. So date range pe ho raha hai, so basically I'll do a partition on date range. That is how you have to answer the thing. So if you want to learn, if you are thinking how I can learn these things of data engineering, we have an end-to-end bootcamp, a dedicated bootcamp on data engineering. From zero to high paying data engineer you can become, and it is a job focused resource. We have dedicated modules for everything. That is, we have PySpark, we have Python, we have SQL, we have Databricks, we have Azure, we have GCP projects we have done Snowflake dedicated module, we have Spark dedicated module, we have Pandas dedicated module. We have done many projects, we are doing many projects. We have interview focused module for like discussing these kind of 40-50 problems that can be asked in the interviews. So those kind of things are already there. So 100% these will help you. If you want to become a data engineer, you can get into the bootcamp, very affordable bootcamp. Link is there in the description with the coupon code also. You can use that and get into data engineering. And if you have any kind of doubts, you can ask in the comments also. And we have a WhatsApp support number also. If you have any doubts for the bootcamp, you can go on the WhatsApp support number and ask your questions. That is how you can get the things. Next thing, let's talk about the partitioning versus indexing, like when to use and what is the difference between these two. That is the third question. That is, explain when you would use partition over indexing and vice versa. So firstly, whenever you are working with OLTP system, online transactional processing system, so OLTP systems you will be using indexing will be faster because there are two types of system, OLTP and OLAP systems. So in OLTP system we'll use indexing. It is faster, selective lookups will be there, smaller results it will give, because OLTP systems like MySQL, like PostgreSQL or Oracle SQL, those kind of things, or MySQL server. Okay, these are the SQL platforms. These are the OLTP systems for transactional databases. Okay, transactional databases will be there. Insert and update commands will be more as compared to in every query it will be more. Next thing is OLAP system. That is, if there I'll use like partitioning, because OLAP systems are more about your warehouses or your lake houses, like BigQuery is one of the warehouse, Teradata is one of the warehouse, your Synapse Analytics is one of the warehouse, Databricks is one of the lake house. That is how you the difference between the things. Snowflake is a data warehouse. That is how you large analytical system scans if you are to do. So OLAP systems I will use, and I'll use partitioning there. Physical data segregations for the query pruning will be there, and columnar engine will be there for file skipping and all. So bonus point will be Z ordering if you want to use Z ordering, and data clustering if you can use. These are the concept of the lake house that you can use. You can discuss about columnar file skipping, like basically we can use partition Parquet and the ORC files basically, or Avro files basically for these things. So definitely these kind of things are there, and it is very important to answer like this only if you want to showcase in the interviews that you are a good person to hire. So these are the things, these are points you have to focus on. Next thing, fourth one is that handling the skewed data. How exactly you will handle the skewed data in the Spark. So basically the scenario is one of the customer holds around 40% of the record. So this is a classic example of your data skewness, and very data skewness is the main real business problem in any kind of business you are working or any kind of projects you are working. This problem you will face, that like classic this thing, joins on the key and single task is running for about 45 minutes, and other task completed in 2 minutes. This is a classic example of the data skewness. So in the interview, how exactly you will be able to fix this data skewness and distributed join. So basically, firstly I'll try to detect it. How? Via the Spark UI. I'll go to Spark UI, see the histogram, what is the stack color, what is the most amount of time it is taking. The solution is sorting. Sorting is one of the great technique that adding random suffix skewed key I'll add that will distribute the data partition randomly, that will be evenly distributed. Next thing is basically broadcast. I'll broadcast if there are multiple smaller tables to avoid the shuffle entirely. If I want to avoid, so that is how I'll do a broadcast on that. Or I'll use AQA, adaptive query execution. I'll use that will be helping me to adaptive query execution will be automatically helping me in the query handling, skewness handling, it will be helping. So this will be showcasing you the distributed system thinking. That is very, very important. That is how you answer in the interviews also. Next question is basically late arriving data. Very common question this also. Late arriving data will be asked to you, and in this most of the basically what is happening, there is a scenario is basically your data pipeline closes at your data pipeline will closes at midnight, but 3% of the yesterday's event, basically yesterday's data is coming between 2 to 6 a.m. today, after the batch has already completed. At that time it is coming. That is called as late arriving data. Different kind of data, late arriving data is coming. So how exactly you will handle those? So how I'll do that? The strong answer will be sliding window reprocessing I'll do. That is effective. Different kind of rows that are left, that will be loaded. Next thing, watermarking logic I'll apply to define the acceptance and the latenciness. Next thing is merge base. I'll use merge intos. I'll use upsert to instead of overwriting the things. Better upserts and the merge intos will check that basically what kind of data was not present. So it will handle the previous data also, and incremental loads also it will handle. Idempotent design I'll make so that if I rerun it by mistake, or if I rerun the whole pipeline also in the failure scenario, or by mistake also anyone reruns it, no duplicate data is getting entered. So that is how I'll maintain updated at columns for the audit trials. If I'll do audit, I have to do audit. So that is how I have to do. So this is also a classic example, very, very important to understand about the late arriving data. It can be asked 100% in your interviews. Okay, that is how you have to answer. Next question is the sixth question, that is designing idempotent pipeline. So very, very important. What is idempotent pipeline? Whenever you're talking about idempotent pipeline, how exactly you have to do, and why does it matter? Firstly, whenever you are trying to, idempotent pipeline is something like you are running a pipeline and again it is producing the same result. It is not duplicating your data. Like first time you ran it, somewhere it failed, and again you ran it from the start. If it is running also, then also it is not loading the data, loading the duplicate data to the target table. That is called as idempotency. Okay, safe retries will be there. So idempotency is a cornerstone of reliable data engineering pipeline. If a pipeline fails or it reruns, so the output should be identical, no duplicate rows should be added, no inflated matrices should be there and no corrupted state should be there. So basically that is called as idempotent pipelines. Definitely this is how you have to answer the things. Next thing is debugging. Whenever questions will be asked, debugging questions will be definitely there. How you will debug your errors. So basically there is a scenario. After adding the new join to the revenue pipeline, total revenue jumped from 30% overnight. No upstream data change, stakeholders are alarmed. So now basically how this revenue jumped 30% overnight. So basically how you'll figure out, I'll try to figure out via the joins error. Joins will cause these kind of problems, because if joins are like this, different kind of data will be added and you will be not able to figure out how the data got elevated. Basically that you have to figure out. So you will be checking the cardinality, 1:1, 1:many, many is to none, and whatever the things are that you have to figure out. Next thing is, do you have to detect the many to many explosion via the row count comparisons you have to do, where the rows are getting elevated. Basically you have to fix by fix, you have to see. Next thing is, you have to pre-aggregate before just joining to the multiple like this thing. You have to see, basically pre-aggregate and see basically how much rows this is giving. A, how much row gave, B, how much row gave, and at the last, what is the expectation. If it is more than expectation, that is the culprit. There you have to solve the problem. So that is before and after validations you have to do 100%. Otherwise you will be not able to understand that what is the problem and where you are going to get those kind of things. So that is how you have to do that thing. Next thing is basically why Spark shuffles is expensive. Very very important to understand. It is a classic problem of spark shuffling, basically. That is, explain the spark shuffling, the operation in this. So whenever you are talking about the input output up, when the data moves, whenever you are talking about spark, you are talking about distributed system. There is a worker node, there are many worker node, there is a driver program, there is a driver node also. So data moves across the executor over the network, and the slowest transfer path will be there whenever the data movements will be there, shuffles whenever it will be there. Disk spills can happen. Next thing is serialization cost will be there. Data must be serialized. Send deserialized data should be sent. That will be adding a overhead whenever every hop will be there. Next thing, stage boundary you have to figure out. Basically, what is the stage boundary and all. That is how you have to figure out those things. Ninth one is basically a small file problem. Small file problem, that I have told you. That is in the previous also video we have discussed about the small file problem. Mostly what happens whenever you are having multiples, like hundreds of small files, and there are two scenarios. One scenario is 100 of small files are there, and same amount of, like 50 GB folder is this one also, and 50 GB folder is this one also. So this is taking more time because it is having multiple smaller files, but this is taking less file because it is having big files. Okay, so we have to optimize it. We have to compact those things. Very very important. We have to fix it. We have to schedule compact job. We have to control the right side, how it is happening, the coalesce and the repartition we have to, so that skewness is not there. Small file writing is happening multiple times. You have to figure out and solve that. Otherwise your program will drastically become very slow. That is how you have to figure out those things. Very very important. Next thing is designing a pipeline recovery strategy. Whenever you are talking about pipeline recovery strategy, whenever it fails, your nightly batch fails pipeline at 3 AM, by 7 AM downstream, like this will run, your dashboards and all will run. So basically, how do you design a pipeline that recovers gracefully from the failures? So firstly, checkpointing, you will enhance that resume, whenever resume logic will be there in the checkpointing, so that it starts from wherever it failed. Okay, that should be there. idempotent write should be there, so that no corrupt data is there. If a rerun also happens, alerting should be there in your mail IDs or on your phone. You should get your mail, like these kind of alertnet should be there, so that you get those kind of fallback plans should be there. Runbook should be there for the most common errors, so that anyone from the team who is present in that shift, he can also solve those kind of errors. So this is how you answer these things, and these kind of problems can come there. These are just these 10 problems, and related many problems can be made from this, but you should be aware about those things. This is how in data engineering the questions will be asked, these kind of scenario based question. And if you want to learn about these things, as I have told you, we have a bootcamp. We have an end-to-end bootcamp for it. Link is there in the description. The DataX data engineering bootcamp we have, that is a job focused bootcamp, end-to-end data engineering things. People have already got through these things and got into the project. Like if I showcase you some of the Discord members, like we have a Discord community, we have these many people. We have sent the cake also to the people who have got placed. So we have posted here, many people are there. We have posted some of the things, and definitely you can also get through the things. People from different domains have got into data engineering. They have got from about 300% hike, 200% hike. So very great hikes they have given through this bootcamp. So definitely you can also get, link is there in the description to enroll. Coupon code is also there, and if you have any doubts for this particular bootcamp, you can ask on the WhatsApp support number that I have also given in the description. So those are the things, and very very important. Judge the senior candidates, very very important. Debugging skills, scalable awareness should be there. Architectural vision should be there. Trade-off quality should be there. Debugging approach you should know. So very very important. So these are the things. Thank you so much for watching this particular video, and you should think about the as a person who is a data engineer, who is thinking about the business scenarios also. And this was all about the video. Thank you so much, and we'll be posting more videos like this. Please subscribe to this channel, and we have an Instagram community also. You can follow Data with Anurag is there. You can follow me there also. Thank you so much. Bye bye.